and invisible, whether they be thrones or dominions or principalities or powers. All things are created by him and for him. He is before all things, and by him all things consist. Okay, everybody look at the binomial expansion theorem. This is lesson 77. Shh. So we're going to do something a little bit trickier than what they have in the book. They'll do it a little bit later. But instead of this one that they have in the book, where they're taking just x plus y to the 7, let's change it a little bit. And let's make it 2x plus y to the 7. So we're just going to make it a little bit more complicated so that you see how this works. Now remember, if I have something raised to the 7th power, it's going to have how many terms? 8 terms. It's going to always have one more term. All right, so here we go. We're going to start off with a combination of what? 7 things taken 0 at a time. Combination of 7 things taken 1 in. Combination 7 things taken 2. Combination 7 things taken 3. Combination 7 things taken 4. Combination 7 things taken 5. Combination 7 things taken 6. And I'm out of room. Combination 7 things taken 7. So we have 8 terms that we have to figure out. Now what is the combination of 7 things taken 0 at a time? It is 7 factorial over
0 factorial.
0 factorial, 7 factorial. This is always going to be one of them. These two will add together to give you always your top number. Okay, so this is going to wind up being 1, isn't it? Remember, 0 factorial is always 1. So this is going to be 1. Now, the combination, this one's going to be 7 factorial over what?
1 factorial, 6 factorial.
1 factorial, 6 factorial. Answer what, Zach?
1. Just kidding.
Wow. 7.
7, thank you. Because these two will cancel with just a 7 left. Okay? Shh. Guys, I don't need it. 2 factorial, what?
5
factorial. So this is going to be what?
21.
42.
It's 21.
7 times 6 divided by 2. 21, right? Am I right? 21?
No, it can't be 21.
Well, 7 times 6 divided by 2.
Oh, never mind. You're so dumb.
No.
Yeah. You're so dumb.
No.
7 factorial over what?
3 factorial, 4 factorial.
3 factorial, 4 factorial. That's going to be 7, 6, 5. The 4 will cancel. And then 3 and 2, which will cancel the 6. 35. Okay? Then down here, what's this one? 7 factorial over 4 factorial, 3 factorial, which is 35. 7 factorial over
2 factorial,
5 factorial, 2 factorial, which is 21.
I'm guessing 7, 6.
Okay, so we're guessing 7 and we're guessing 1, right? And we're right.
Yes.
Now, I'm going to start the expansion of the parenthesis. This is the number that has to go in front. This is your coefficient. Okay, which remember you could also get from Pascal's triangle, but it takes a lot of work just to get there because you got to go down all that way. You can make an error. Okay, so now we're going to do what? 2x to the what? 7, 2x to the 7, y to the 0. Remember, it's going to have these same two numbers here for exponents. Okay, and then this next one, I'm going to draw a little line.
Wait, why'd you get the 2x?
The 2x is right here. I changed the problem. 2x to the 7, y to the 0. Huh? I'm going to change it even more. Let's make this a minus sign.
Oh my goodness.
Okay, so now this is going to be a minus y to the 0. I'm just trying to show you how to do something more complicated. Okay, so now we're going to have 2x to the what?
6.
6 negative y to the 1. Okay, so then we draw the next one, and we're going to have what? 2x to the 5 negative y to the 2. Okay, then this one over here will be what? 2x to the 4, negative y to the 3. We draw it again. So we have 2x to the 3, negative y to the 4. Now we go again. 2x to the 2, negative y to the 5. Okay, then we go to the 7 here. 2x to the 1, negative y to the 6. And the last one is 2x to the 0 and negative y to the 7. Okay, now once you've got all that done, you would be able to write all 8 terms by simplifying them. Okay, I'm not going to take the time to do all of them. Well, let's just pick one and simplify them. Okay, so we're going to pick this one right here, the 21 one here. We're going to pick this term and we're going to break it out and simplify it. Okay, so this is going to be 21 times what? 2 to the 5th would be what? 32. X to the 5th. And negative y squared is just going to be y squared. The negative will square out. Okay, so then I would have to figure out what's 21, somebody with a calculator, what's 21 times 32? Peter.
661.
661.
What if I get it right?
That can't be a 1. It's got to have a 2 on the end.
662. 672.
672.
Close.
Okay, and then x to the 5th, y squared. So that would be, well, if they tell you to find all 8 terms, I just found one of the terms. Now, all 8 terms are added together, right? Now, this is the first term, but notice that the first term has a 0. First term, second term, third term. Okay, so the third term is going to have a 2. All right? So the third term is going to have a 2 on that one. So if I was told just to find the third term, that would be the third term. If I was told to find all 8 terms, I would have to go through the simplification of all 8 terms, and then I would add them all together for the sum of this right there. Okay? So that is your binomial expansion theorem. It is tedious, but it is not difficult. There's nothing hard about it. It's just tedious to get them done. Okay? Everybody look over here to 78. And we're talking about the hyperbola. Okay? Hyperbola.
What is that used for?
Okay, we've done problems that you've had to multiply out 3 times and 4 times where you could have used. Okay? So like if I gave you what is x plus y cubed, instead of having to multiply it out 3 times and FOIL it, you could do this right here. Because that's the same thing.
Is it really faster though?
If you're having to do it to the 7th, it sure is.
Oh, okay. Huh? Cute. Oh my.
Sensei, were we supposed to take a quiz today?
Huh? Yes, we were supposed to take a quiz today.
Okay.
Okay, let's go ahead and take a quiz today.
It's
We
open
don't
book.
have
Wait, what?
time.
Open
Yeah.
book.